Welcome back. We are still on the topic construction. In the previous video, we learned about the locus of a point. In this video, we are going to learn about the locus of points equidistant from a fixed point. Locus of points equidistant from a fixed point. The word equidistant means equal distance. In the previous video, we learned that the locus of a point is the path that a point creates as it moves from one position to another position under a given condition. Here, we are going to learn how to find the locus of a point equidistant from a fixed point. So here, the condition is that the points should be equidistant from a fixed point. To understand this very clearly, let's consider this simple example. We have a point here, I'm going to call it point O, and we have a ring here. The distance between point O and the ring is 3 centimeters. In this example, I'm going to consider point O as a fixed point, so the position of point O does not change. We have point O here, and we have the ring here. The distance between point O and the ring is 3 centimeters. Now, let's do this simple exercise. We are going to move the ring to different positions, but we will do that under one condition. The condition is that at each one of these positions, the distance between the ring and point O should be the same. We have seen from here that the initial distance between point O and the ring is 3 centimeters. So at each one of these new positions that we are going to move the ring to, the distance between the ring and point O will also be 3 centimeters. Now let's start. To do this, I'll measure 3 centimeters in this direction, then I'll move the ring from this point to this point. The ring used to be here, so I'm using these short dashes to show that. Now I've moved the ring from this position to this position, but the distance between the ring and point O is still 3 centimeters. I'm going to move it to another position. So I'll measure another 3 centimeters in this direction, then I'll move the ring from here to here, just as I've done. Then I'll measure another 3 centimeters, this time in this direction, and I'll move the ring again to the new position. After that, I'll measure another 3 centimeters and move the ring to this new position. I'll measure another 3 centimeters again and move the ring to the new position. I'll measure another 3 centimeters and I'll move the ring again to this new position. I'll measure another 3 centimeters here and move the ring again to this new position. We started from here. We know that the distance between this point and point O is 3 centimeters. So there will be no need measuring the 3 centimeters again. So finally, I'll move the ring to its original position. As you can clearly see, using this condition, the ring travels around point O in a circular path. I'm going to use these short dashes to show the path through which the ring traveled. And as you can see, the short dashes forms a circle. So when you move a point around a fixed point such that the distance between the point and the fixed point does not change, the point will travel through a circular path. From the previous video, we learned that the path that a point creates as it moves from one position to another position under a given condition is known as the locus of the point. So here, the path that the ring creates as it moves from one position to another position under the condition that the distance between the ring and the fixed point should be the same is known as the locus of the ring. And as you can clearly see, the locus of the ring is a circle. This is because in a circle, the radius is always the same. So when a point travels through a circular path, the distance between the point and the center of the circle will always be the same. So from here, we can say that the locus of points equidistant from a fixed point is a circle. What this means is that if we draw a circle like the one we have here with a center O, the circle gives us the locus of points equidistant from the fixed point, which is the center. Let's assume that the radius of this circle is 3 centimeters. This means that the circle gives us the locus of points 3 centimeters from the center O. So we have seen that the locus of a point equidistant from a fixed point is a circle. The fixed point will be the center of the circle, and the radius of the circle will be the distance between the point and the fixed point, which is the center of the circle. Let's apply what we have learned here to solve some questions. We are going to solve two of them. Here is the first one. Using a ruler and a pair of compasses only, construct I, triangle ABC, such that the side AB is equal to 7 centimeters, the side BC is equal to 6 centimeters, and angle ABC is equal to 105 degrees. II, construct L1, the locus of points 4 centimeters from C. In the previous videos, we have solved a lot of questions on using a ruler and a pair of compasses only to construct a triangle. So I'm not going to go through the process of constructing this triangle in this video. I'll move straight to the second part of the question. But before I do that, I will take a 5-second break so that you can pause the video and construct the triangle before we move on. Now let's continue. So for the first part of the question, we are asked to construct triangle ABC with the side AB as 7 centimeters, the side BC as 6 centimeters, and angle ABC as 105 degrees. That is what we have here. Let's move on to the second part of the question. It says that we should construct L1, the locus of points 4 centimeters from C. So the locus we are going to construct, the question says that we should call it L1. And it is the locus of points 4 centimeters from C. So we are going to construct the locus of points 4 centimeters from a fixed point, which is point C. We have seen that the locus of points equidistant from a fixed point is a circle. The center of the circle will be the first point. So here, point C, which is the first point, will be the center of the circle. And the radius of the circle will be the distance between the points and the center. The distance given to us here is 4 centimeters. So it means that the radius of this circle is 4 centimeters. So this locus L1 will be a circle with point C as the center and a radius of 4 centimeters. To construct this circle, you pick the ruler and you measure 4 centimeters with your compass. So I have my compass here. You measure 4 centimeters. 4 centimeters will be 40 millimeters on my ruler. Now, I've measured 4 centimeters. I'm going to take the ruler off so that we can continue. We have now measured 4 centimeters using the compass. We are going to draw a circle with point C as the center. So you put the needle of the compass on point C, just as I've done here. Then you turn the compass and you draw a circle. We are now done with the compass, so I'm going to take it off. This circle will give us the locus of points 4 centimeters from C. The question said that we should call the locus L1. So this circle, which is the locus of points 4 centimeters from point C, will give us L1. Let's move on to the second question. The second question is A. Using a ruler and a pair of compasses only, construct I, triangle ABC, such that the side BC is equal to 8 centimeters, angle ABC is equal to 45 degrees, and angle BCA is equal to 60 degrees. II. Construct X, the locus of points 3 centimeters from A, and B. Measure BY, where Y is the point of intersection of X and the line AB. Just as we did in the previous example, I'm not going to go through the process of constructing this triangle in this video because we have solved a lot of questions on using a ruler and a pair of compasses only to construct a triangle in the previous videos. So I'll move straight to the second and third part of the question. But before I do that, I will take a 5-second break so that you can pause the video and construct the triangle. Now let's continue. For the first part of the question, we have constructed triangle ABC. The side BC is 8 centimeters. Angle ABC is 45 degrees and angle BCA is 60 degrees. Let's move on to the next part of the question. It says that we should construct X, the locus of points 3 centimeters from A. So the locus that we are going to construct, the question says that we should call it X, and it is the locus of points 3 centimeters from A. So we are constructing the locus of points 3 centimeters from a fixed point, which is A. We have learned that the locus of points equidistant from a fixed point is a circle. So this locus will be a circle with the point A as the center and a radius of 3 centimeters. To construct this, I'll bring my ruler and my compass. Then I'll measure the 3 centimeters on the ruler using the compass. So I'll put the needle on 0 and stretch the other part to 3 centimeters, which will be 30 millimeters on my ruler. I've now measured 3 centimeters on the compass. I'm going to take the ruler off so that we can continue. We are constructing the locus of points 3 centimeters from A. I've measured 3 centimeters using the compass. So you put the needle of the compass on point A, since that is the center of the circle. Then I'll turn it and construct the circle. I'm going to take the compass off since we are done with it. This circle will give us the locus of points 3 centimeters from A. The question says that we should call this locus X. We have that here. Now let's consider the last part of our question. It says that we should measure BY, where Y is the point of intersection of X and the line AB. So we have point Y here, which is the point of intersection of the locus X and the side AB. We now know the position of Y. The question says that we should measure BY. To take this measurement, I'll pick the compass and put the needle on point Y. Then, after that, I'll stretch the other part to point B, since we are measuring BY. So I'll put the needle on Y and stretch the part holding the pencil to point B, just as I've done here. I've now measured BY using the compass. To know the exact distance, I'll pick the ruler and put the needle of the compass on 0. Then I'll read where the part holding the pencil touches the ruler. On my ruler, the part of the compass holding the pencil touches it at 43. Remember that the scale I'm using on the ruler is in millimeters. So 43 millimeters will be the same as 4.3 centimeters. I'm now going to take both the compass and the ruler off. So the length of BY is 4.3 centimeters. Thank you for watching this video. Subscribe to this channel for more videos. In this video, we have learned that the locus of points equidistant from a fixed point is a circle. The center of the circle will be the fixed point, and the radius of the circle will be the distance between the point and the fixed point, which is the center. In the next video, we are going to learn about the locus of points equidistant from two fixed points. Bye bye.